Alrighty, here we go. Number 11. About your reaction time. Ruler, let the other end hang. Hold your thumb and index finger. Catch it as quickly as you can. And then if it falls this far, what's your reaction time? Alrighty. So, our Y is a written Y. And I'm going to start off with the ruler is in free fall. Thus, accelerating downwards at little g. The further the ruler falls, the longer time it took me to catch it. Yeah. I think that's about it. Oh, maybe I should mention, what speed does the ruler start at? Who's working on this one with me? Because a lot of you picked it. Okay. What speed did the ruler start at? 0. Yep. That'd probably be good to know this. The ruler started from rest. Alright. I think that's good for a Y. So, I know about its acceleration because I'm assuming this is happening on Earth. It's the only planet I've visited. I know how far it falls. And I want to know the time. So I'm looking. I know there's a relationship between acceleration, distance, time, displacement, those type things. So I'm going to grab my general kinematics equation here. And use that. So I'm going to call where I catch it. Oh, which way do you guys want to call it positive? Up or down? Down? Okay. So we're going to call down as positive, just to remind ourselves. So this is where I catch it. What unit should I have D in? Meters. Meters. I should make sure that this is in meters. D naught. Well, that's going to be 0. I'm going to call where I released it, where my friend released it 0. Why? Because it's easier. It was also at rest when it started, so there's another 0 right there. Time is what I'm looking for. Acceleration, oh, I know that's little g. Or, in this case, positive 9.81 meters per second squared. And t again is what I'm looking for. So I'll just find delta t. And nice, that'll be in seconds. And that, my guess is that's what they wanted it. Let's see. Yep, seconds. So, yeah. That'll do it. Alrighty, let's look at number 17 here. The power output of a fly as it walks straight up a window pane at that speed. Ooh, grams and centimeters per second. And then they want the answer in milliwatts. So I gotta watch my units, right? Alright, so when I look at this, I think of two different ways to approach it. I know to go straight up the window pane, the fly is doing work because it's increasing its gravitational potential energy. And so I could say, well, let's look at how much it does moving for a meter or something. Or I can say, well, it's got a force that it has to do that work against. What force does the fly do work against? to go upwards. Gravity, it's weight. It's gravity, yeah. And so I can look at it from that standpoint also. I think that's what I'm going to use. But if I look at my Y port, I'm doing an energy bar graph. So I need to add in some PE grav. Put that in there. Here we go. Now, at the bottom, the fly is moving. Let's give it some kinetic energy. Make that look better. And I'm going to call its PE grav at the bottom 0. Is that okay? Can I do that? Yeah. And then, let's see, as it goes up, I'm going to assume that it moves at a constant rate. So that means its kinetic energy is going to stay the same. It's going to be the same at the top and the bottom. But I know at the top it has some gravitational potential energy. I'm going to give it a lot. And that has to come from somewhere. So where did that gravitational potential energy come from? The work it did, the external work, yeah. Go fancy. So yeah, that's what I would have as my bar graph. And let's see, then this one will be in, make it red centered. Let's see, B block day 2, problem 2. Okay. So I want to make sure right off the bat that I can convert grams to, what unit of mass should I use rather than grams? Kilograms. And centimeters per second to meters per second. And then I'll have to, at the end, I'll get watts, and I'll need to convert it back to milliwatts. Right? So, good test of my metric prefixes there. I'm going to graph my power equation because the problem tells me it's about power. And I'm going to take the approach where I'm going to deal with the fact that the fly is pushing against a force, and that force is its weight or the force of gravity. So I'm going to grab this one, my force of gravity relationship there. So let's see, I want to know how much power this fly has. And I'm going to use the form of power where it's the force that it's working against and the velocity that it's moving at. And we think about that, velocity is distance per time, force times distance is work, over time is power. That's how that equation works. I think it was outlined in your reading and such. So the force that this is going against is my gravitational force, mg. And then my velocity I know. Right? They tell me my velocity. And so in the end I know my mass, I know what planet I'm on, and I know my velocity, that's a check mark on the V. And I want to know my power. or that's going to give it to me in watts. And then I want to convert to milliwatts. Which number is going to be bigger, watts or milliwatts? Milliwatts. So I'm just going to make a little note to remind myself. Bigger. That way if I get a smaller number, I know I just messed up which way I convert. So give it a try. Let me know if you need my help. I'll give it a try to make sure my solution works. We'll meet in the middle. Alright, so 13 was the next one on the list. And this is one that has a force diagram. It's you have this mass of airplane and it wants to slow down as it moves along the highway. And it has this much braking force. What is the airplane's acceleration? Alright, so let's do I'm going to use this to do the force diagram. So there's my plane. We'll give it wings. How about that? And moving in that direction. Since it's slowing down, that means its acceleration is opposite its motion. It's going to have a force of braking that I'm going to call that S sub B. Of course, it has weight down and normal force up. Yeah, that's it. So that would be my force diagram that I would need in there. I got everything going on. My forces are touching my object. My acceleration and my velocity are not, because they're just describing the motion. Let me grab that, put it in my notes so I have it. I don't want that one, I want this one. And this will be B block, Day2, problem 3. Alright, so I know the mass in kilograms, that's good, no conversion there. I know the force, and I want to know the acceleration. I know the net force, which is important, not just the force, but the net force. And I want to know an acceleration. So I'm going to grab my Newton's second law here. And as I said, I know the net force. They tell me that. And nicely they give it to me in newtons, which is the units I want. They tell me the mass, and they ask me for the acceleration. There you go. That's it.